5.3, graphing from standard form. Okay, before we, in unit 5.2, we were able to find all of those key features using standard form, and now it's time to graph. So what is the information we need in order to graph? First off, we need to have the vertex. Okay, so remember the vertex is going to be our x value is from our axis of symmetry, so we'd write it as negative b over 2a. And then our other part, our y value, we get from plugging in our x into our equation. Plug into equation to give us this, the y value. Okay? All right, so, and then the second thing we need is the growth pattern. And we'll talk about that in this section. Okay? And once you have those two things, you can graph any parabola, okay, giving an equation. And when you do graphing, we need to make sure we have 5 points. Okay, and we'll talk about that some more as well. All right, but first, let's look at the parent graph of a quadratic. Y equals x squared. So this is the most basic quadratic you could ever have, and this is what it looks like. Okay, if we were to draw a graph or write a graph for x and y, where it goes from x being 3, then 2, then 1, then 0, negative 1, negative 2, negative 3, we could come up with the y values just by looking at our graph. So if we go at 3, that would give us 9. Or you could also plug this into this equation. 3 squared is 9, and 2 squared is 4, 1 squared is 1, 0 squared is 0, negative 1 squared is 1, negative 2 squared is 4, and negative 3 squared is 9. All right, so let's mark these in here in that graph. You could do them on the other side as well, symmetric, so we know exactly where those are going to be. Okay, and then looking at this table, let's look at the difference. If we move from 0 to 1, that's a difference of 1. It moves up in the y direction 1. Okay, if we go, our next step is going to go from 1 to 2. That also gives us a move of 1. And then from 1 to 2. And then 1 to 4, it gives us 3. We go up 3. And then if we move x from 2 to 3, that gives us a 1. But our vertical, our y value, gives us 5. So we can learn from this that for every step over in the x direction, we're going to go up 1, then we're going to go up 3, and then we're going to go up 5. And if we keep going, it's going to go 7 and 9. So we have I'll write over here, we have an odd growth pattern. Or I guess we have that. Odd growth each time. Okay, so for example, once we have the vertex, we go over 1, and then we'll go up 1a. Okay, and we'll talk about that a, and then we'll go over 1, and then up 3a. So this a for our parent graph, a is 1. All right, so this is how the growth goes if a equals 1. But if a is not 1, say it's 2 or a half or negative 2, then all we're going to do is we're going to multiply our growth by a. All right. So, for example, this is the mother graph or the parent graph, mother graph. Okay. Let's say y equals 3x squared. Okay. If we were to plug in 0, let me get a different color. That would give us 0. And then if we did our next step is we're going to go over 1, and then we're going to go up. Here we'd put in our x is 1, because that's we just moved over 1. That would give us 3 times 1 gives us 3, so it would go up 1, 2, 3. All right? And then if we went to the next step, would go 3 times 2. That would give us 6. So we'd go to 9. All right, and it would mirror over because it's symmetric. It would look like something like this. Okay. So really, what we need to memorize is that we're just going to go over 1, and then we're going to go up 1a, and then we're going to go over 1 again, and we'll go up 3a. And you could keep going on. You could say 5a, 7a, 9a, 11a, if our graph was big enough that we could do that. Obviously, for this one, we couldn't go to the next step because it would go out of the graph. Okay, so let's do some examples. Make sure we're doing standard form. Remember, standard form is y equals ax squared plus bx plus c. We'll need to make sure we have it in standard form when we do our vertex. Okay, and all right. I'm trying to see if there's anything else I'm missing. Okay, we'll do some other examples. Like, for example, we'll have a equation like y equals negative x squared, and what that happens when we have a negative in there, and things like that. Okay, so let's do some examples. So first thing, we want the vertex. So to give us the x value of the vertex is going to be negative b over 2a, just like we learned in 5.2. So we plug that in, we get b, this is b, a is going to be 1. Okay, so we plug that in, we get negative 6 over 2 times 1. That gives us 3. So, and then our y value, we're just going to plug in x equals 3. So we're going to get 3 squared minus 6 times 3 plus 13. All right? And then you can use your calculator at this point, or you can do it by hand. We get 9 minus 18 plus 13, and that gives us 4. So our vertex is going to be 3, 4. So we'll go to 3 and we'll go to 4, and that would be our vertex. And if you wanted to, you could do your axis of symmetry if you wanted to. Okay. All right, and then after that, we're going to do our growth pattern. All right, so what we're going to write down is going to be 1a and 3a. We plug those in, that gives us 1 times 1, gives us 1, and 3 times 1 gives us 3. So what we're going to do is we're going to move over 1, and we're going to go up 1. Over 1, up 1. And then we're going to go over 1 and up 3 from our growth pattern. All right, and then you could do the same thing. If we go left, and then we'd still go up 1, and we'd go over left 1, and we'd go up 3. Okay, or you can just mirror over the axis of symmetry. And then from there, we can just draw our little graph. All right. As long as you have those 5 points, and you give it a shot to try and make a nice parabola, you'll be great. I know some of, like I don't do the perfect parabola. But as long as you have those 5 points, like I mentioned at the very top, that we need to have 5 points. One including our vertex, and then 2 from both sides of the growth pattern. All right, and that's it. So we go over 1, up 1, over 1, up 3 for that example. Okay, B, let's do the same thing. We want to find our vertex. So we're going to do x equals negative b over 2a. And that gives us a negative 2 over 2 times 1. And that gives us 1. Then we do our y value. We plug our 1 into our equation, this equation. And that gives us 1 squared minus 2 times 1 minus 3. And that gives us, we could simplify, that gives us 1 minus 2 minus 3, which is negative 4. So our vertex is going to be 1 comma negative 4. So I'll put that dot, or that point on. We go to 1 and negative 4, just like that. Okay, and then we're gonna, if you want, you could draw your axis of symmetry. Okay, and then we're gonna do the growth. So we're gonna do 1A and 3A, and that gives us 1 times 1 and 3 times 1. So this is just the same. This is 1 and 3. All right, so we'll go over 1 and up 1. Over 1, up 3. Okay, and here, since we have room, if we wanted to, we could do 5A. So we'd go over 1, would go up 5. All right, and then we're just going to mirror over the axis of symmetry. And then from there, we can come up with our parabola. Something like that. Okay? All right, let's do